These are the types of questions that could change your grade by 1.5. So you get this right in an exam and you have basically given yourself a chance to improve your grade by 1.5 grades at least. Welcome to this lesson where we are going to be looking at modeling with differentiation. So stay tuned and I'll see you after that intro. All right, so to start off with, we are going to look at this question over here. Now, these questions are typically always having the same format. They give you some sort of 3D shape where they ask you to show something. So they might give you the volume, or they might give you the surface area, or vice versa, or otherwise. And we're going to look at a couple of questions in this lesson. Now, before we start this question, just to point out to you that the top over here is missing. So there is no face at the top. It's a tank that you can put water in. Anyhow, so what do we have? We have the surface area as 54 meters squared, and we have to show the volume is equal to this. So to start off with, we will find an equation, a formula for the surface area. So what do we have? Now, we have this square at the front here, and we know that this is a square. We want to find the face over here, the area of this face, but we don't have a length here. So what I'm going to do here is I'm just going to introduce a length. Let's call it y, okay? So to begin with, the surface area, which is, let's call it SA, that's surface area, is equal to x times x, which is x squared. And we have two of those, so we'll have 2x squared. Then we have this side over here, which is going to be y times x, or x times y, so plus x times y. And how many of these do we have? Well, we have one here, we have one at the back, so that's 2, and we have one at the bottom because y times x. So we have 3 lots of those. So this is our surface area, and that is equal to 54. So we can write in here 54. So this is what we have so far. Now, let's move on to the volume. We need to introduce a formula for the volume. So how do you find the volume of a shape, a cuboid like this? It's the area of the cross section, so x, so V is equal to x times x, which is x squared, times by the y. So that's what we have for the volume. Now, notice what it wants us to have in our final version. There is no y in here, like these two have a y. So, and it wants us to have v equals. So that means we'll make y the subject of this equation and we will substitute it in there. So if you have a look at this, how do I make y the subject? Well, I will take this over to this side and then divide by 3x, giving me 54 minus 2x squared is equal to 3xy. So now I will divide by the 3x. So therefore y would be equal to 54 minus 2x squared divided by 3x. What I will now do is I will substitute this value of y in here, giving me, therefore, v is equal to x squared, which is already part of this, and in a bracket we'll go all of that because that's the value of y. So that will be 54 minus 2x squared all over 3x. Now, I will simplify this. Now, before I start multiplying out, you can see here I've got x squared and an x here, so I can cancel that, and then I can multiply this out. So I get v is equal to 54x, and then multiply over here, so 2x cubed, all over 3. Now, all over 3, I could write like this, and 54 over 3 is equal to 18x, and then I'll have 2 over 3x cubed, and that is the answer that they want me to show. So now going on to the second part of these questions is usually following the same pattern. It will ask you to make or to find the maximum or the minimum value, in this case of v, and then it will ask you to prove whether it's a maximum or minimum by doing the second differential. So in this case, the next part of this question is saying, given that x can vary, use differentiation to find the maximum or minimum value of v. Now, you know that when you're dealing with maximum and minimum, you are differentiating, and therefore you will be differentiating this. So for part B, we'll be finding the dv with respect to x, and we'll differentiate this, giving us 18. The 3 drops down here, cancelling with this, so minus 2, take 1 away from the power. So this is what we have. Now, maximum and minimum points are also stationary points, so we have to make this equal to 0 to find what the value of x is at those stationary points. So make this equal to 0. I have 18 minus 2x squared. Take the 2x to this side. Divide by the 2. So I get x. Sorry, that should be equal. Divide by the 2. So that I'll get 9. And x is equal to plus or minus 3. Now, before we decide to use either plus or minus 3 or use one of them, if you go back to the question, x cannot be a negative number because it represents a length, and lengths, as we know, cannot be negative. So therefore, we will be using the positive value of x. Now we will find the value of v by substituting the x into this formula. So what do we have for v? We have 18 times by 3 minus 2 over 3 cubed. 3 cubed is 27. 27 divided by 3 is 9, times by 2 is 18, and 18 times 3 is 54. So therefore 54 minus 18, the answer is v is equal to 36, and it's in centimeters, it's in meters and cubed. So the volume is 36 meters cubed. All I have to do is prove whether or not this is a maximum volume or a minimum volume by differentiating again, i.e. finding the second differential. So let's do that up here. I will be finding d squared v dx squared by differentiating this again. So the 18 goes, the 2 drops down, so minus 4x. So now you probably can see what the value is going to give us, but we'll still substitute the value of x in here. So we'll sub x equals 3 into this, and we get minus 4 times 3, which is minus 12. And we know that minus 12 is less than 0. And if you have a value which is less than 0, so if you take this as your stationary point, the gradient is now less than 0. Therefore, it is a maximum point. So therefore, this is a maximum point, and V is a maximum volume. Hope you understood that question. We'll now apply this same pattern again on another question. Right, so let's have a look at this question. This is a nice and interesting one. We have an equilateral triangle here. So because it's equilateral, I will label this x and here x as well. And therefore, if this is x, that's also x as well. Now, what do we know about the angles of an equilateral triangle? We know that they are 60. So all of these are 60 degrees, okay? So what does it want us to do? It says that the area of this pool is 50 meters squared. Show that y is equal to this. So we need to have a formula for calculating the area, right? So let's do that. What do we have? We have this triangle. We're going to work out the area of this triangle. So how do we do that? We know that half AB sine C will give us the area of a non-right angle triangle. So x times x divided by 2 times sine 60. Or in other words, half times x squared times by sine 60. That is the area of this triangle. So let's just rearrange this. So sine 60 is root 3 over 2 times by a half. So therefore, we'll do that half here times by x squared, which also simplifies to root 3 over 4 x squared. So this is the area of the triangle. The area of this rectangle is going to be y here times by x. So plus xy. So the area of this semicircle is going to be pi r squared. Now r, the radius, is going to be half of that x. So it's going to be half of x squared. And it's going to be divided by 2 because it's only half of a full circle. So let's just put that half there. Let's tidy this up. So what do we get here? So we know that this, so let's just write this half pi first. This will be impacted by the square. So it's going to be times by x squared over 4, which simplifies to 1 over 8 pi x squared. So this is the area of this semicircle. Let's put it together with this. So plus a half pi x squared. So here, right there, is an expression for the area of this pool, which we know is equal to 50. So what we can do now is just make this equal to 50. All right, I'll get rid of this circle as well, so it's not in the way. Okay, right. So what does that leave us with? It leaves us to just simply rearrange this in terms of y and make the rest of that. So let's go. Now you'll notice that 50 has been divided by x, so it may actually be helpful right now to actually divide by x because everything else has x as well. So if we divide this throughout by x, let's divide that by x, well, when we divide this by x, we can just cancel that really. We can cancel that, and we can cancel that. So what we're left with, 50 over x is equal to root 3 x over 4 plus y plus 1 over 8 pi x. And now if you look at this, you can see that we can make y the subject by leaving it here and taking all of these to the other side. So if we take everything else over to the other side, we can have 50 over x, we can have y equals here, minus 1 over 8 pi x, and minus this onto the other side as well, so minus root 3 over 4x. So now all we can do is, if you look at this, we can just tidy this out by taking out x over 8 from here. So we can rewrite this as normal, so 50 over x minus, and we're taking out x over 8. So we'll have our bracket here and here. So what does x over 8 needs to multiply over here to give us the rest of this? Just pi. And here we've got minus outside, so this is going to turn into a plus. And then we want to have a root 3 over 4, and it's going to be multiplied by the 8. So something's going to happen with the denominator to end up with a 4. So we need to have a 2 root 3 in there, giving us the final answer that we want. And this is the final answer as they wanted us to show. Now the next part of the question says to do the same thing, but this time with the perimeter. So let's begin. Let's work out an expression for the perimeter of this. So we know that x plus this, which is y, plus the circumference or half the circumference. So let's just add the rest of the x values in. So another x, so that's 2x, another y, so that's 2y. So let's just put the 2y in, and then we now just need to work out half of that circumference. So pi times d, so the diameter is x, so it's going to be half pi x. And this is equal to the p perimeter. Now we just need to make it look like that. By substituting the y value, we already know y is equal to all of that, so we can now just plug y in right there. Right, so now I'm going to plug in our y value in here. So let's have this. So p is equal to 2x plus 2 bracket. I'm going to put all of that in here. So 50 over x minus x over 8 pi plus 2 root 3. And then close that bracket. And then we have our half pi x. Right, let's open up this bracket now. So the 2 and the 50 will give us 100 over x. And the 2 and the 8 will do some simplifying. So therefore that would be x over 4 pi plus 2 root 3 plus half pi x. Now the next step you could actually do in a number of ways, all right, depending on how you're looking at it. But if you notice here, you've got the 2x and this half pi x. And this bracket already is looking like what I want to sort of achieve. So what I can do right now is I can actually put these together by having the same denominator. But before I do that, I'm just going to write them next to each other so you can actually see what's going on. So half pi x. Now, I want to give this the same denominator as that. So that will need to be multiplied the top and the bottom by 2, giving me 2 over 4 pi x. And this one will need to have a fraction first of all, so over 1, and then times by 4, so that's going to be 8x over 4. And now I can put them together. So how do I put them together? I can take out the common x over 4 out, so x over 4, bracket, and then what's going to go inside here is going to go 8 plus 2 pi. So hopefully it's still following. All I've done is just I've put the 2x and this together like that. And I'm going to write this right next to it. But before I do that, I'm going to put this next to this one first. So I'll have x over 4 pi plus 2 root 3, and then I'll have my 100 over x. All right. Now, the next step is very, very important. You could see that I'm kind of getting there now. So here, I will take out a common factor of x over 4 and put these two into one big bracket. Okay. Now, I'm running out of space, so I'm going to rub out some of those things. In fact, I won't need to rub out. I'll just work along here. All right. So have a look here. So I'll have x over 4 out. I want to take the common factor out, okay? So what do I want? I want 8 plus 2 pi. So when this multiplies with all of this, it's going to give me that. Next, I'll have a minus. So this will now need to multiply to give me all of this. Now, we've got to be careful here because this plus and a minus will be a minus overall. So here I will have pi and it will be a negative here, so 2 root 3. And this is factorization. Now I have the plus 100 over x, and this is all equal to p. I know that this has been long so far, but bear with me. I thought I'll do a hard question just to give you a very, very straightforward one and then a difficult one that you might find in the exam. Right, so I'm almost there now. All I've got to do here now is do some simplifying. The 2 pi and the pi, they have 1 pi between them. So I'll have p is equal to 100 over x, just to make it look like this, by the way, plus x over 4, and then 8, and then 2 pi minus pi is just pi, and then minus 2 root 3. And that is your final answer. I know that was quite difficult. Hopefully you're still there. Go back and rewind if you need to sort of go over any steps. But we're going to continue the next part of this question, which is to find the minimum value of p given your answer to 3 significant figures. So this is our p. So before we can find the minimum value, i.e. differentiate, we need to standardize this. So that can be written as x to the minus 1. We multiply this out, so we have 1/4 pi x. Let's write pi first, pi x. And then we have 8 over 4, which is 2, so plus 2x. And then 2 and the 4 will become a half, so plus a half, so root 3 over 2x. Okay, so this is what we're going to differentiate. So dp over dx, the minus will come down here, and that will be x to the minus 2. Now the power here, 1 will come down, so therefore 1 over 4 and then give you 0, which is 1, so that just becomes 1/4 pi. This will be a 2, and this will just become root 3 over 2. I could rewrite this as over x squared. So now I just make this equal to 0, and I have the rest of that. And this we'll just write as it is. Now we're going to take this 100, minus 100 over x squared over to the other side. So we have 100 over x squared is equal to 1/4 pi plus 2 root 3 over 2. Now the easiest way to do this would be actually to swap all of this, go down here, and the x squared comes up here, giving us x squared is equal to 100 all over 1/4 pi plus 2 plus root 3 over 2. And to find what x is, what we can do is square root both sides. So we have x is equal to that. And the answer to this is x is equal to 5.23 ... Now, the final answer has to be to 3SF, not this. So you can plug as much of this as possible into your value for p now and get an answer for p. So if you do that on your calculators, you get 29.2 to 3SF as a value for p. Finally, you want to prove that this is indeed a minimum point by finding the second differentiation. So we are differentiating now all of this. So the minus 2 will come down here, giving us a positive 200 x to the minus 3. Now, all of these are constants, so they all disappear. This is all you have left. So this is 200 over x cubed. You're now going to substitute the value of x that you had from earlier. And if this is a positive or a negative, that will determine whether you have a maximum or a negative point. And we have 8.07 times 10 to the minus 3, which is a positive value. So therefore, you have a positive gradient. And therefore, this is a minimum value for your P. And that is the end of this question and also the end of this lesson. Hope you enjoyed this lesson, guys. Give this video a thumbs up and I'll see you in the next lesson. Bye for now.